Hello, we are here for one more lesson of this SprutCAM video training course, and this is part 3 of the same topic. We've started with the previous videos, which we called as it should be, part 1 and part 2. So part 3 of the basic technology terms will allow us to see a couple more features or functionalities if you want to call them another thing. We will use the same model as before, as part 4 will be a little different because we will focus mainly in 2D curve machining and options. So with the same model, a couple more things. First, which is quite interesting and I think important to have also a good quality toolpath. We have a feature and I will create a new program. First, okay, I will not need. Finishing plan, it is what we call a copy. Copy because basically follows the shape of the part and it is a finishing toolpath. We have a parameter here called transition, and inside we have this short link that does a very simple thing. It defines a method and a distance where if we exceed on the step what is defined here, the connection between the parallel steps will be on the safe plan. Let us try. You see here that when we go from one step to the other, basically follows the surface, but we can define, for example, a distance of 3, okay? And now the strategy, okay, I have a distance of 1, I will say distance for the step, and we should get, as you can see, okay, every time it changes from one step to the other, we'll go over the safe plan. This is interesting in some options also, but it's another feature which you can use. More connected with both roughing waterlines or finishing waterlines. We can see now these roughing waterlines. We have something called the clear flats. So when we define also the parameters for the toolpath, we have parameters and we have the definition for start height for the retraction, and we can mill it between top level, bottom level. We can define scallops. You know already all of this. But we can have another thing called clear flats, which allow us to obtain a constant stock value. So if we split the part in layers, sometimes when we have a flat area, we can get a different amount of stock. And if we say clear flats, we will obtain an additional layer, assuring that the flat level has the same stock as the other things. So we can try to do something. I will increase a little this guy here for 20. I will leave these clear flats, okay, and let us try to calculate something, because what we expect to obtain now it's a little difference from the layers of the program. Let's try to, I hope that this 20 it is visible, so right, and in this area, as you can see, we have, okay, we have this amount which is more or less constant, okay, with increments between layers. And you can see that we have a different passage here, a different layer in this flat area, to clean this, okay? So this is to assure that after doing especially a roughing waterline type of program, we obtain constant material. Then we have also something called corner smoothing. We've seen something about this in the previous video. In roughing, it's a little more complex because we have a lot of lines. So let's try to create a finishing, and we have this finishing waterline where we can define a couple of parameters. So we can give a quantity, let us say 10, it should be enough. And on the strategy corner smoothing, let us give a nice radius of 2, and let us calculate this, because we should have now, okay, in, I will not say in all areas, I'm not sure. Okay, we have some round radius in some places. In the other ones, let's see if we have some additional okay, we have a radius of 2. We can try to increase or decrease this a little. Let us see the trimming. Okay, surface slope, parameters, also everything. I will take these clear flats out. Now it's not so important in this program. And as you can see, we have this, now it's more visible, we have this small radius every time we get a sharp corner, so much more visible now. This is very good to high-speed milling machines, because the difference between when we accelerate and decelerate, it is less visible, and the idea is to have as constant as possible toolpath. Another parameter we have, it is something called hole capping. And okay, we are here in trimming, so we have the hole capping, and this hole capping is very useful also, because if we have a geometrical model imported, and as you know, SprutCAM is not a CAD software, so we can have some minor things defined, but the ideal is to have a perfect model to machine without any problems. So we may get models with holes, and if we get holes, when the programs are defined, they calculate the space that the hole occupies. But we can define a hole capping parameter where we say that until this dimension, which we can say something, it is not considered a hole. So I don't have any holes in my file here, but it's a very interesting parameter which you can also try and to see how it works. A couple of more features. We've seen a couple of them. This one, machining direction downwards or upwards, okay, it inverts also the direction where how we should work on the part. We have also a very interesting feature, also more focused in roughing waterline under strategy, which is the machining order every time it reaches a closed area, so we can continue doing this by layers, or simply every time we get to this closed area, and finish it and come back to the previous level or layer and continue our work. And we have some interesting features also regarding, and I will use this program here, but I could do it also in the roughing waterline. Let us try it both, and we will see what happens. Lead-ins, lead-outs. So we can have these pretty much standard with on the approach, without approach, so simply a direct approach. Even that we can define safe levels and safe distances, but we can do also these much more interesting arcs or normal or tangent or angle to tangent. I will define arcs. I can have a very nice radius here, angle 45. I can say a little more, so let us say for example 80 degrees, and retraction also without arc, normal, whatever. Okay, let us say normal, and let's try to calculate to see if we can get something nice. So I think on this side we have the entries, which is round, and you see here on the retraction simply straight up. And this one, for some reason, and on this one, normal to the surface. This also depends on the shape that we are working with. Here a little more complex with some different approaches. Okay, it depends on the geometry also, but at least we can try several things to see what happens in several cases that we try to use and what suits us better for this kind of thing. So for the video today, I think these topics, I did a couple more commands and options to your package of tools. A little up front in this course, we will see each type of program in detail, so we will have the opportunity to execute a program and to see results, to play a little with all of these parameters. Meanwhile, if you have any question, any problem, let us know. We say it many times. We will give you all the necessary support, and if possible, and in case of a little more search for information, we have also additional things in our online platform which you can access if you reach us and ask us how to do it.